And I'm happy that the two presenter already talk about the packaging applications and all these things. So it's very easy for the people to understand that thing. So before I'm going to talk about that the natural fiber base and how we have done the two project. So basically, I will first talk about the one of the PhD output, and then I will talk about that one. So before going on that one, I just want to introduce a little introduction about my university. My university is called University Putra Malaysia. It's one of the research-based university in Malaysia. Please go further. And its present ranking worldwide is 143 in the worldwide, and there are different rankings there. Please go ahead. And there are different faculties. We have 15 faculties, 11 institutes, and we have 2 schools, and we have 13 higher education center of excellence. I also belong with one of that one. And we have different international academic programs. And we have just collaboration and all these things. Just move fast, this one just for introduction. This is international collaboration they have. And these are some of the photographs from there, mobility programs and all these things. And this is some summer experience programs going on in my university. And this is a different research cluster available in the university. And this is some commercializations of the in various fields. It's going on that. Just go ahead fast, no problem. These are some of the product. These are some of the international community collaboration. These are the list of the industry linkage with the university. Yeah, this is one of that they already introduced. So just brief introductions about my publication and supervision status. So presently I have more than 500 articles in the Scopus index, and my H index is 63 in the Scopus, and Google Scholar 75, and number of citation in the Scopus and Google Scholar. Presently, I'm supervising 6 PhD students, but I graduated already 26 PhD students as a main and co-supervisor. And I have also published different books and edited books and all this. And this is my research teams long ago. It's before the lockdown, 1 year ago. Some of them already graduated and some of them already working. So to the presentation, I'm going to talk about the introduction, natural composite, natural fiber, composite, and why biodegradable packaging is needed. The earlier 2 speakers already make the clears the thing, but I will give my own point. And I will take one project, which is my PhD student have done, and she's one of the master student from the FRI, and then she graduated from here. And that the food tray from the hybrid composites. And then I will talk about the one international project which I done on the pulp molding product from the oil palm biomass. And we will talk about the project outputs and all these things, how done in this in the limited times. And then I will lastly talk about the different standard worldwide using it, that one. And then I give some brief overview about the market and economy of, say, BIPAC and acknowledgement. Next slide. So if you look into the natural fibers, because today we are talking about the wood and bamboo. So when we look at that one in the fiber, we have 2 types of fiber. We have natural fiber, we have synthetic fiber. When we go into the natural fiber, we have animal fiber and we have the minerals fibers. And one is that which we are talking about, the cellulosic or lignocellulosic fiber. So in that, there are different types of fibers are available on the basis of the source. So when we look into the bast fiber, there are different types of the fibers coming like jute, flax, hemp. And when we go to the leaf, sisal, banana. When we go to the seed, cotton is very much known. And then we go to the fruit, coir, oil palm, and some of them. And then the wood. Wood, we are going to come the 2 types of fiber you can get from the wood. Soft fiber, soft wood and hardwood. Another from the stalk, you have the rice, you have the wheat, barley, and maize. Others the grass. So bamboo is coming under the grass fibers because it's form of the grass. So this is the some of the photograph when you look into the plant. So bamboo is also here, and then further go. And you can extract the natural fibers from these plants by using a different process. You can use the natural process of water rating, or you can use, go second slide. So when we look into the fibers, you can extract the different types of fiber, and it can be the water rating process, alkali or enzymatic, which the process you can go and you can extract the fibers from the different sources, from the bamboo, from the soft fibers, or hardwood fibers. You can extract that fibers, and that fibers have a different types of mechanical and physical property reported in the literatures. Please. So this is when you look into the chemical compositions of the natural fibers. You have, as you know, that when we are talking about the lignocellulosic fibers, we have the three main component in the fiber. We call cellulose, hemicellulose, and lignin. Beside that, there is extractive and all these things. So when we look into the bamboo, bamboo have very good cellulose content, more than 70%. So as you know that the cellulose are giving the main mechanical strength for any application. So the bamboo have very much possibility to use into the advanced application as compared to the wood. Wood have the range is more, compared to 30 to 64%, because as we know that one is a natural plant, so it can be vary from the place to place. So because of that, here the range is uses in there, and then you can look the lignin content is also 10 to 15%. But in case of the hardwood and softwood, the lignin content is good one. One of the drawbacks of natural fiber is the water absorption and the less thermal stability. So you look into the benefit of wood fiber is that one. The wood fiber have better lignin content. So if you want to use the natural fiber, which is you are going to go for the higher temperature, so maybe the hardwood is better in compared to the bamboo fibers. Next. Then we look into the physical property, because what we are talking about the density. So you want to use as a lighter materials, you want to use the heavy materials, and length of the fiber is also matter, especially when you are going to go into the textile or mat form. If you want to make that product from that fiber, must be the length of fiber is higher. So when we look into the bamboo case, bamboo have the density is from 0 to 6 to 1.1, and then the length of the fiber is 1.4 to 5.4, and then when we look into the diameter, also 25 to 40. So it's comparable to the other fiber. The properties is suitable for, and wood case also, the what we call that the length of the fiber is little bit lower, but the diameters and density is also comparable in case of the wood and bamboo fibers with the other natural existing fibers. Please go further. Then we can look into the classifications of the composites, that we can classify the composite on the basis of the materials. You can say the metal composite, you can say the ceramic composite, you can say the polymer composite, and within that you have a fibrous, particulate, and laminate products are there. And when you are going to use the natural based material, then you can say the natural biofiber based composite or synthetic fiber based composite. And within the natural, you can also divide, biofiber, bioplastic, because when you use both the biopolymers, also you are going to use like polylactic acid or bioepoxy or another biophenolic acid, then you can say it's a 100% biocomposite, or you can say the green composite. By other side, we are using the natural fiber, but we are using the synthetic polymers like epoxy, polypropylene, and others. Then we can say, and sometime, because as we know that the natural fiber is not much suitable compared to the synthetic fiber, so sometimes we hybridize, like one fiber have better impact properties, other fiber have better tensile properties. So when we are looking that unique properties, we can go into that type of product. When we are talking about the packaging has a vital role to play in our daily life, protecting food and anything we want to go to the market for consumers, chain supply. This is very important things are there. And it is that how much, like sometime the product they are looking that you buy the product, the packaging product, how long it will last, and it will sometime, it does not matter for us, but for shop it matter, if they bring some product for 2 days, if we do not sell that product, it's going to spoil, and they are going to loss in the lakhs and crore they are going to use, hypermarket, if they have less extension shelf life is there. And when we estimate that one, total plastic consumption in that one, we find out that the 37% of packaging products are made from the rigid and flexible plastic, which makes the plastic the most used packaging material. And plastic food packaging is produced and consumed in unsuitable manners. What we are talking in the earlier presentation. We are using that one. It's a very vital what call the products in our daily life. But what we are doing in unsuitable manner. And when we go into the emissions, and that we, as you know, that the plastic is creating to rise to the greenhouse emission, which the worldwide we are talking about the climate preservations and all these things. And when we go into the recent study estimated that the 31% of the plastic debris in the marine environment originated from the food and beverage package. And we found that the 8 millions of the trucks, that daily, and if you will estimate that 20 or 30 millions going to be into the dumping into the oceans. And when we look into that 2 garbage trucks, per minute in 2030, but it's going further 4 into the 2030. Okay, please. So when we look that the why this biodegradable and composite packaging is needed. First is that the market for biodegradable packaging product is large and growing due to the government regulations, and the awareness of the people is going on. So the demand is high in the market, and the growth is triggered to large extent by the consumer around the world, who are becoming increasingly aware of the negative environmental impact arising from the use of the packaging made from the non-biodegradable materials such as metal, glass, and plastics. The growth further fueled by increasing the environmental regulation, as I say that the different, like in India also, we put the single plastic use regulations and all these things, and which is pushing the industry or the people to look into the how they can reduce this non-biodegradable plastic use. And it's basically a multi-billion business opportunity. And if we look into the negative impact of that, the plastic bags in the marine and others, that, the turtles and other things are taking and poison them, digestion, and causing the starvation for them. When we look into the seabirds, 44% of seabirds eat plastic mistaken for food eating, and they have these types of things coming out from their stomach, And we estimated that the 20 cows die every day after digesting the plastic. Now we come on to the one PhD student have completed, and she already graduated under my supervision. She have developed that one packaging tray by using a coir and pineapple fibers reinforced polylactic acid hybrid biocomposite for food application. So we try to analyze, go further. We analyze to take the literature reviews and all this one, and we find out that there is most of the people work on the coir, but they work on the synthetic polymers, and they work on that the coir was separately, but nobody work on that to hybridize the two natural fibers. Please. So we try to prepare the coir fibers, and then we prepare the what you call as the pulp fibers, and then we have also done the surface modification, because we know that the fiber and polymers have not better interfacial bonding. So if you want to improve the interfacial bondings between the natural fibers and polymers, you need to modify the fibers. So this is the flow chart of that one. We done that the processings and all this thing, and then we done all the testing for getting the exact the properties of that composite further. So this is the experimental we try that in the different temperatures, and we then the milk compounding of that and the hot press, and then we cool down and 3 minutes, and then we can get the composite for that. This all are the already published things are that so you can get the whole detail. Just I'm giving the superficial overview here. So we have a fibers, PLA granules, and internal mixing fibers and PLA, and then the grinding mixed fibers and PLA, and then we have done the hybrid, and then we done the prototyping food tray from this. So we try to do the characterizations of the coir and pulp fibers, and we have find out that the cellulose content in the coir fiber is 42%, and the pulp is case of that the cellulose content is the high, and also the diameter of the fibers in case of the coir is higher, and density is almost equal for that and the lignin content is also higher in the coir fibers, and moisture content and all these things are there. Further, So we done the what you call the characterizations of that one. We done the SEM. We look the surface untreated fibers, and we look with the NOH and saline treated, and we have also done with the calcium hydroxide to look at that one. Less study done on the calcium hydroxide to look the compatibility, and we look into the untreated fibers, and we have the stress and strain curve is here further. And we have further studied the tensile properties of the untreated and treated coir fibers and pulp fibers. So we find out that one, when we are doing that one, the treatment of the fibers, the modulus is reducing, in compared to untreated, and even case saline and the calcium hydroxide. The reason is behind that one, when you do the cleaning and all these things, some of the content of the from the fibers is removing from there to make the interfacial bonding, and sometime it will reduce the mechanical properties of the fibers. And we also done the interfacial bondings between that one uh, untreated and NOS. So we find out that one, by treatment, the interfacial bondings between the fibers and with the polymers is better. Further. This is my email ID. Thank you so much.